Hello everyone. In this video, we'll show you how to create a room-wise heat load calculation using the Reonic app and your LiDAR scanner on your iPhone and iPad. That being said, the LiDAR scanning to obtain a room-wise heat load calculation is only possible with Apple Pro devices featuring a LiDAR scanner. You can search if your current device already has a LiDAR scanner by looking at the product specifications. In this case, we're using an Apple iPad Pro, and we have already downloaded the Reonic app. We're going to open it here, and we are met with our home screen. For this particular case, we'll just open up a test offer that we created named Demo LiDAR. You can see it right here. If I'm opening it up, I can swipe up and see that there's a room-by-room heat load calculation button. Just going to press this one, and we have a few steps to go through. First one is to account for the existing heating. This could already be done inside the portal, inside the project on your laptop or in the browser. And the second step would be to look at the room-based heat load calculation, looking at building properties, looking at basic materials, and lastly, we actually do the scan to go through every room and account for all the superstructures that the LiDAR scanner can scan. Wonderful. So we'll start with the existing heating. I'll just open this up. In this case, we are looking at a gas heating, and we can use this little button here, calculate from consumption values or costs, to get a nice indication. In this case, we are looking at 1,500 euros per year in heating costs, which is roughly around 125 euros per month. I'm using this. You can see that this is already taken over here at the top. I can now go and already save and skip to the next part, which is if we go back, you remember the building properties. In this case, I would need to give a few information points here. Firstly, how many residents are we speaking of? In this case, it's 2. The building year is 1980 in this case. Temperature preference is a normal 20 degrees. Building length and building width is usually something we can roughly estimate just to get a sense of the hydraulic pressure that is needed to get the water from A to B when we look at radiators. So in this case, I'll go for 10 times 10 meters. Air tightness test we don't have. Soil depth in this case is 0 because we are looking at a ground floor. Shielding is normal. We have expert settings as well if you want to look at thermal bridge factors and average temperatures, reference height, when it comes to looking at the location of the building. In this case, we'll leave it as is and go to the next part, which is basic materials. The great thing is that the basic materials are already pre-filled based on the year of construction of the house. Obviously, we can switch around in here. So basically, if we, for example, look at exterior walls, we have the value, the vertically perforated brick, which is what we were seeing in the 1980s. We can also select other building materials or directly type in the U value if we have it. Why is this important? Later on, when we do the room-wise scan, these materials will be the default for all walls, windows, and ceilings and floors that we scan. So we don't need to enter these manually every time that we scan something in the scan part later. In this case, we'll leave these as is 2. And then we have something here at the lower part, which is the valve. So you can basically select a default valve when it comes to the radiators. This is something that helps when accounting for a radiator in the scan, but these can also be filled out later if you don't know them now. We'll also leave these blank for this example. If I go to next, it is basically preparing us now for the scan. First step here would be to add a story. In this case, it's the ground floor for us. And once I've created the story, I can then go here and start the scan. Wonderful. So you see the camera is starting. The camera is just there to give us a visual representation of the scan. The LiDAR scan itself is using the little LiDAR sensor on your camera notch. So I'll just go and start story scan. And you can see it gives me a little indication of me moving around my camera a bit to give more information to the LiDAR scanner. The great thing is it also accounts for furniture to an extent. So the couch here, for example, is accounted for, and make sure that all the little white lines which are helping the LiDAR scanner to detect, for example, in this case here, a door, or in other cases, a window, that this is all featured in your little 3D model that you can also see down below. In this case, it looks like it has accounted for most of the architectural structure here. One thing that we need to do before finishing this room preview is to account for the radiator that we have in here. I usually just do a little photo using the photo icon here on the right, and it will do a photo for me later to give more reference when filling out radiator relevant data. In this case, I'll just finish the room and go to preview. And we now have a little 3D model here at the top that we can also zoom in on or move. And the cool thing is there is a bit of logic behind. So I'll just switch over the tablet to have a better view here. All windows that are detected, which is, for example, the big one here on one of the sides, are already per default given a wall type facing outside. So this is why it is tinted into blue. And we have also managed to detect a door. So we have this little red door here on the side. And the great thing is we now have the option before going into the next room to account for all inaccuracies or level of detail in this room. So first thing I would try to, therefore I'll go back to the top view here. I'll go and type in living room, which is the name of this room, and later on gives me easier understanding when looking at the entire story, which room was which. Room images, I could take images here for references if I want. The interesting thing is ceiling and roof. In this case, the ceiling direction is to another heated room above us, and we don't have a roof to the outside. Then we have the floor. The ground floor goes to an unheated room. So underneath my living room is an unheated room, and the surface area from the scan was 19.9 square meters. Fantastic. We have accounted for radiator. You can see the image has already been put in here. The great thing is that I can now go in here and select the type. In this case, it's a 22 with a heightness of 500 millimeters and a width of 1.50 meter. And yeah, the valve in this case, I'll just leave blank for now. And yeah, now I can also use my 3D model to tap on walls and basically say, okay, this one is going to a heated room. This one, however, goes to a other building. And yeah, this one here goes to a heated room. This one here goes to a heated room. The small one also. So in this case, it looks as if we've accounted for everything. And if we have done so, we can go and save and scan the next room. And if I click on this, only then I'll move into the next room to give the scanner the option to account for the position of the next room to properly put out the layout of the entire story later. So I'll meet you later when we have the entire story ready and go through all of the rooms now in the same fashion as we did with this one. All right, we've just finished up with the story scan, and you can see that all the rooms are perfectly laid out. So we have a hallway, we have the living room and home office, kitchen and bathroom, and we've also named them all correctly. And now I can go to save and exit in here. And you can see we have a total of 5 recorded rooms on the ground floor. And we could now add a second story, go up and scan more rooms. But for this example, it already shows how it is done. And if we are finished with all rooms and all stories, only then we click on finalize. And in this case, we'll see each other in the portal again, where we can make last changes and get the final report out for the heat load calculation. Thank you for watching.
Hello everyone, and welcome back to the second part of the video, where we will go through the LiDAR scan that we just did in the last video and have a look at it from the portal view. So in this case I've opened up the exact same planning, and the great thing is that whenever something is scanned in the app and finalized, this is already synchronized with your projects inside the browser. So as we've opened up the demo LiDAR account and are going to planning in here, we can see that under building and heating load, we have the room-wise heating load and hydraulic balancing already in place. And now, why is this important to open it up in the portal again? Basically to get out the report in the end and to do changes and corrections in case we found a few inaccuracies or would need to switch something around. So if we go to edit in here, we have the overview, again very similar to what we have in the app, with building properties, basic materials, the floors, data validation, and in the end results, radiator replacement and reports. Validation and results are the two new parts that are not to be found in the app. These must be done inside the portal. So I have two views here that I can switch from, which is basically this list view, or structured view as we call it in here, and 3D view. And the 3D view is basically allowing us to have the 3D model at a large scale, go through it again, and then open up the respective floors and go through living room, hallway, kitchen. We also see that the room on the 3D model on the right is highlighted. So this is why it is super helpful to name the rooms, to have a sort of overview when you look at the 3D model here, so you know which room is which. I usually prefer the structured view because it's like the menus are always shown here, and I can just scroll down and switch around stuff. So basically we could, for example, go through the bathroom here and make changes to the radiator if we have not accounted for that in the scanning yet. We could also like say, okay, this is a 550 in height, and it wouldn't make it would help us to account for this. If we are happy with all the rooms in here, we can switch over to validation. Just one more thing, we have these little indications, these little icons here, whether a room is heated or not heated. In this case, the hallway here is this little snowflake icon indicating that we have not placed a radiator in here. In this case, this is also true because this room has no radiator, but just an overview, so you can always account for the rooms that are not heated and the ones that are. If I hover over this little window here at the lower point, I can also always open up the 3D model. And the cool thing is, inside the 3D model I also am able to click at rooms and at walls. So in case that I know from the 3D model that this wall here, for example, was facing the outside air, I could select this here as such, and can also say, okay, this wall, which is then automatically selected, is going to outside air. And if I go outside this room, I can also see that this was taken over. So this wall here is also now blue, indicating it's facing an outside air. Wonderful. So next up, we would go to data validation. In here, you would receive a checklist indicating on instances throughout the scan where there could be an error. So something like two rooms that are facing each other have different wall indications, whether it is facing a heated or unheated room. So there is quite a bit of logic behind, which helps you to navigate through your scan. And I can also show you the warnings. In this case, it was mainly for us leaving out the valves on the radiators, but this is okay. We can live without it for now. And yeah, you can also ignore most of the warnings. And then there's also a checklist that is helping you to account for everything that is usually needed to get a good scan and a good heat load calculation out. So basically, are all rooms recorded correctly? Are wall types checked? Is roof and ceiling data input correct? Do we account it, or did we account for all the radiators, all the windows and skylights and dormers if we have them? And yeah, basically a good checklist to go through, especially if you do this for the first time or are still relatively new to this. Cool. So next up we would go to results, which is basically showing us for the first time what the heat loss is that we accounted for. Obviously in this case a relatively small layout of rooms, so the heat load here is just above 3 kilowatts, but it's also giving us an indication where the heat is lost mainly, so through the outer walls, through the windows, floors, ceilings and roofs, with the heat loss in total watts in areas, and also in terms of transmission, so how much of the warmth is lost throughout the materials for the buildings that we've selected, so the U values here. And yeah, the cool thing is that we can also now select the flow and return temperature to account for which type of heat pump are we supposed to plan. You can just click on that here, and yeah, I can just select a flow return temperature, and I can also compare the temperatures. I can therefore click here on that little button, and it will give me an indication which radiators are at the moment correctly sized for example, a flow return temperature of 45 degrees and 35 degrees, so relatively low, but in this case bathroom would be enough. Hallway has no radiator, so it's unheated. Living room, however, radiator seems too small, at least it is missing 719 watts of performance here to yeah, heat the room to the desired temperature, which we set to 20 degrees. If we are looking for a yeah, flow return temperature of yeah, 45 35. If you move up the ladder here and go through like the highest flow return temperature, which is 60-50, you can see it is actually then helping us, and the room would be heatable here. Obviously this is not the ideal temperature for the heat pump that we are looking for to have it effectively performing, but yeah, this is a helper to see which radiators might need replacement, or which rooms we will not get to the desired temperature if we are using a heat pump in this specification. Wonderful. So next step would be radiator replacement. We'll do a separate video on this. You can actually then replace radiators that are not sufficient when it comes to the performance that they currently have. But in this case we'll skip this and go straight to the report, which is super cool. It calculates for a few seconds, and then you have your entire room scan report, basically including every room, the building data obviously, and later on also the settings for every radiator to account for the selected flow return temperature. If we account for the valves, it also gives you the settings to put into your valves to account for the radiator being correctly adjusted. Wonderful. So this report can be downloaded, and then we are basically through with the LiDAR scan part of this episode. The next one will go through the MCS related heat pump performance estimate, which is also relevant. And yeah, seeing you in the next video, and have a good day.